Questions on any one of those three? Remember, it's critical you understand all three of these. Going once, going twice. If you don't understand this, you need to come and get help. That's what I'm referencing towards you. This test is all predicated, you know those three things. As we move on, you're going to see we're going to do this over and over and over again. If you can't recognize alternate interior, corresponding, or same side, you need to come get help. Speaking on which, we had homework. And if you look at your homework, if you look at number... Oop, I got the wrong ones here. If you look at the very last one.
That's my question.
Yep.
It said 8, but I thought it was 2.
It won't be 2, but look at number 26. If you wrote 8 there, look at your last one. Everyone should have their homework out, looking at the very last one. Don't know, I have to repeat myself. Look at the last one on your homework. If it says 8, you more than likely just copied the answer key. And remember I said that's the dumbest way to do this class is to copy the answer key. I'd much rather you say, I didn't understand it. I'm going to ask questions. I'm going to get it. 8 is 100% incorrect. If you would have emailed me, you would have got a bonus point. Yeah. Yeah, I didn't check yours yet. But yeah, if you erased it or something or changed it, remember, do not change it unless you know for a fact it's right. You have to be able to support it. So if you changed it to 8, and you're not just copying the answer key, you must have had some way to justify it. But there really wasn't a way to justify it, because if I draw a transversal connecting two lines, let's go 1, 2, 3, 4, 5, 6, 7, 8. There are 4 pairs of vertical angles. There are 4 pairs of vertical angles. There is 1 and 4. Those are vertical angles. There is 2 and 3. Those are vertical angles. There are 5 and 8. And there are 7 and 6. Just because the answer key says something doesn't mean you should just copy it. Remember I said the only reason why you change something is you're like, oh, that makes sense. Not, I'm just going to copy whatever Mr. Pabian wrote. Horrible way to do this class is just copy the answer key. There are mistakes out there, and you get bonus points if you just email me with those. And someone in here got that bonus point. They told me about it, and they got a bonus point. That's 3 out of 2 points. It's actually worth points. All right? So pay attention to the homework. All right. Other than that, what other questions do we have from the homework? Go, Griffin.
Number 16, I was just kind of confused when they combined the two.
Number 16, they kind of combine the two.
With just the angle number 5, and they used letters as the other one.
Oh, yeah. I know what you're talking about. So number 16. Well, note the angle I want isn't actually numbered. The angle I want is actually a combination of 2 and 1. It is them added together. And I don't want to have to say angle 1 plus angle 2 forms bigger angle. Instead, they used PSR. PSR means you start at P, you go to S, and you go to R. That means the angle I'm talking about is this whole angle here. It's a combination of 1 plus 2. It's the only way I could have done that without using, because I couldn't use numbers there. And I can't call it angle S because angle S has 3 different angles it could be. Angle S could be angle 1, could be angle 2, or it could be that big angle there. And then they talk about angle 5. Angle 5 is this guy. I highlight that one. Remember, a lot of these, for people that struggled on this, just involve you highlighting it. That's why I always have problems with telling you guys to highlight these. I saw people that had questions on these, and I didn't see anything highlighted on it. Highlight those angles, particularly if they're 1 or 2. Does this make sense now why I use 3 letters, Griffin?
Yes.
Okay, so just make sure you follow that. So sometimes I can give you numbers. Sometimes I can straight up say angle P. I could say angle P because that would only be 1 angle, or I can give you 3 letters. All right, so that would be corresponding angles, right? Corresponding angles. Does that one ask for anything else? I would ask for our transversal. So our transversal would definitely be that SR, just to finish this problem. And we should put a line above that. We can either use that symbol or we can use the full line symbol. And our lines would be that red one and that blue one. So we'd have to go PS and QR. I'm going to use the two different symbols I would accept. I'd accept you saying it's a line segment, because line segments can be transversal, so can the full line. And just because I don't have the arrows everywhere doesn't mean they don't exist, because you can turn it into a line by just making it longer. Yeah?
Instead of PS, can we use SR?
We could use, instead of PS, could we use SR? Well, SR has to be our transversal. Are you talking about flipping the letters? We could have used SP there. Yeah, we could have flipped the letters, but SR is our transversal, so it can't be one of the lines. Remember, our job is to highlight and realize which one connects the two lines, that's SR, and what are the two lines that are being connected. All right, more questions?
Could you go over number 4?
Sure. Let's look at number 4. So number 4 says, this is probably the hardest problem out of all of these, because they're telling you to locate this type of thing, locate your transversal and locate your two lines. So we're looking for two things that are obviously corresponding angles, which can be really hard to pick out. What I picked out for corresponding angles, remember they have to be same side of the transversal, one has to be in the exterior, one has to be in the interior, basically same location. The easiest one that I noticed was 7 and 6. And the reason for that is, just in your mind, you kind of have to be able to highlight stuff. And you can draw in here. You're using a pencil, draw in there and erase it. But if I highlight those two particular angles, do you see a transversal and two lines? Does it make sense that these are in the same location, bottom right, bottom right?
Yeah.
Okay, so that's what makes these so difficult. Don't get bogged down in these. I'm not going to put this on a test. This is just for you to struggle through, honestly. Struggle through these, look for things that match this stuff. So if I ask for alternate interior angles, well, see if I start at 7, there's not an alternate interior angle over here. So that's where we start picking things out. Well, if I do 5, well, it could be this whole thing, but that's not labeled on there. So then I start looking at 2. So for alternate interior angles, we might start looking at 2. Well, if I look at 2, I have to look at the angle that's formed by 2. And then if I draw one more line up here, this is a transversal. These are my two lines. So 2 and 3 would be alternate interior angles there.
Okay.
Do you see the alternate interior angles once I have it highlighted there?
Yeah.
Ish? Okay.
It's just kind of weird because of like the
Oh,
angles.
very weird.
Yeah.
I 100% agree. This is the hardest question you'll ever see on these. If you can do these, if you can sit down and just struggle through these, everything else becomes a little easier after that. That's why I chucked that hard one at you.
Okay.
All right, other questions? Go.
For number 3, for 5, for angle 5, angle 6, it says right, alternate interior.
I agree with that.
With it, I put none because I thought the interior was 3, 4, 5, 1.
I got what you're saying, but the thing is, I don't know what the interior is until they talk about the angles. So we can't just look at the picture, I'm going to draw my interior here. We have to look at the angles that they tell me. Notice how they just specify 5. So let's highlight 5. Let's put a little dot there. And 6 would be, let's use kind of this color. Would be right here. Now, did I highlight that middle line? No, I did not highlight that middle line. I highlighted the top line, the bottom line, and maybe middle line was a terrible, because I saw you shaking your head. You're like, yeah, that's a transversal. But did I highlight this line here? No. So your job is to actually go, they didn't talk about that line, so that line doesn't exist in this problem. Now the interior becomes, that gray was horrible highlighting, but your interior actually becomes those lines. So I could have 50 lines on there. And depending on what angle I talk about, depends on what the interior is. Because that's why I want you to picture this is my transversal, and these are my two lines. That's all I'm talking about. Highlight, highlight, highlight. Okay? Flynn, did you have a question? Okay. Going once. We got lots to get to, so going twice, going 3 times. All right, sold to the highest bidder. Today we're talking about, we're going to show one proof. Today is not proof day. Tomorrow is our proof day on this stuff. Today we're just learning a postulate and 2 theorems. And tomorrow we'll get a new theorem sheet. You know your theorem and postulate sheet that you hopefully have not lost because you can still use it on the next test. We're going to add another sheet to that. So we'll staple something onto the back of it. And on that sheet, the very first thing it's going to say is it's going to say the corresponding angle postulate. The important thing here is the word postulate. If I'm going to use this in a theorem, I have to say postulate. We're going to have a converse coming up. So we have to signify that this is a postulate. Now this says if 2 lines are parallel. I'm going to highlight that. I'm going to say if 2 lines are parallel. If you have 2 parallel lines, so that must mean we're given 2 parallel lines. Can you pick our head up? We are given 2 parallel lines. Are cut by a transversal, then the corresponding angles are congruent. If you have 2 parallel lines, then corresponding angles are automatically congruent by this postulate. Now, here's my question. On that picture, did I highlight 2 corresponding angles? Are 1 and 2 corresponding angles? Yes. Absolutely they are. They're absolutely corresponding angles. Now, does it say anywhere on there that A and B are parallel? No. So, as it's stated, I cannot use this postulate. So, unless they're parallel, you can't use this postulate. Do they look parallel? Yeah. Are they? No. Unless I say they're parallel or you prove they're parallel, they're not parallel. I'm going to go ahead and say they're parallel. And the way I'm going to do that is I'm going to use little symbols. I'm going to use 2 little arrows to say they're parallel. Kind of like those tick marks said things were congruent. 2 little arrows tell you that they are parallel. So if I had more parallel lines, I'd use 1 arrow on all of those. Now they're parallel. Now I can use this postulate. So this postulate says if these are parallel, so if, and I'm going to use another symbol again. This is the symbol for parallel. If A and B are parallel, then angle 1 is congruent to angle 2. Note it's got to be if. Can make sure unless you're doing something for this class. So if A is parallel to B, then angle 1 is congruent to angle 2. Alternate interior angles start with the same premise. If they're parallel. I'm going to highlight these because we're going to have a lesson where they're not parallel, where we have to first prove they're parallel to use these postulates and theorems. Note, I am now on to a theorem. Alternate interior angles theorem. This is a theorem. Postulate, theorem. If you have parallel lines, then alternate interior angles are also congruent. So alternate interior angles and corresponding angles are both congruent if you have parallel lines. Now note, I'd never said that these are parallel. I'm going to add a slightly different symbol. If you're on the same problem and you have multiple different styles of parallel lines, we can also use 2 arrows. Then you look for 2 arrows to find that other parallel line. This is also predicated on them in parallel, so I'd put if it turns out that A is parallel to B, which it did, then 1 and 2 are alternate interior angles, right? I didn't mess that up? Do those look like alternate interior angles?
Yes.
Yes. Okay. So then angle 1 is congruent to angle 2. All right. As a reminder, postulates are given. Theorems can be proven using postulates. So we use postulates to prove theorem. So although we're not really doing proofs today, we're going to do a proof in class just to know that they exist with these. And I also want to point out that proofs with these aren't that bad. They're not that bad. You just have to kind of work around to find them. I find these proofs a little bit more accessible. So we're supposed to prove that alternate interior angle theorem, in fact, is true. Now, whenever we're proving a theorem, I cannot use the actual theorem to prove itself. That'd be redundant. You'd be eating yourself, basically. So we cannot use the alternate interior angle theorem. So let's figure out how we're going to do that, but let's go ahead and just start. Let's just start with the given. I'll tell you, one person didn't write the given on the test. That's automatically 1 point off. And it's just copy and paste. That just shows me that some of us are just copying the answer key. We're not learning from the homework. We're just copying stuff. All right, so I have L is parallel to M. Bless you. Bless you. All right, we need to prove that 4 is congruent to 6. Now, we cannot use the alternate interior angle theorem. I can't just say, oh, they're congruent because of the theorem. That's gone. So we can cross that theorem out. What other postulate or theorem did we learn today? Tito?
Corresponding angle postulate.
The corresponding angle postulate. And I want to get to 6. What's the corresponding angle to 6? Raise your hand. Yeah, Marco. 3 is not, that would be the same side interior. Careful there. Well, 5 would be our corresponding angle. So if I look at 6, 5 would be a corresponding angle. So let's use that fact. Let's start with that fact. Let's say we know that 6, and this is how a proof would look like that. We'd go, you know what, angle 6 is congruent to angle 5. And that's because they're corresponding angles, but we need to put our corresponding angle, and we have to add the word postulate. That's important. Otherwise, it's wrong. You can't just say the corresponding angles. You have to use the postulate because you will have converses.
Could you just abbreviate that to CA?
Yes. Yep. I didn't want to for your notes, but you can definitely put CA, and I'll be doing that from the future. I'll be able to put CA post.
Okay.
You know me, I'm lazy. Shorten stuff as long as I can read it. All right, step 3. Some of us might be able to see step 3. I need to somehow relate this to, because I want to get to 4 and 6. I want to somehow get to 4. How does 4 connect to either of these angles? How does 4 connect to either of these angles? Luke? They're vertical angles. And vertical angles, which two are vertical? 5 and 4. So 5 can lead us to 4. I should probably do that in red because I started there. So we start with corresponding angles. Then I go to 4. So I can go ahead and say, you know what? Angle 5 is congruent to angle 4. Step 3, that's vertical angle. Perfect. Vertical angle theorem. All right, now stay with me here. I have 6 going to 5, 5 going to 4. Is there anything that links all that stuff together? Yeah.
If 6 goes to 5,
6 can go to 4, and why? I assume you know because you said transitive property. There you go. Transitive. And we can just put transitive. You can put prop if you want. I'm just going to put transitive. How was that proof? Yeah.
If I just did table 6 because of substitution, would that be right? Or would that just...
That would work. Yep. Transitive is a little bit more eloquent here, but substitution would work there.
You have to use the reflexive, right?
Oh, yes. We should probably do one more. Symmetric. Symmetric is correct. You know what I do to get away from that? I just would have wrote that as 4s. If I was a student, I'm just like, I forget what reflexive or symmetric one I'm using here because this does need to get flipped. I would have already written that as 4 is congruent to 6 because you can write transitive in any order you want. So we should, the way I have it written, I would have to flip it, which would be symmetric. Can we go back to Michael's question? Michael, you asked, can I use substitution there? You actually can't. And we'll talk about that in the future. I wouldn't take any points up, but technically it's incorrect because we're going to learn that substitution is a property of equality, and this is congruent. We're going to talk more. Remember I said we're going to get a little bit more divide between those two in this chapter? That will be the divide, that if there's congruent symbols, you can't use substitution. Am I going to be picky on that? No. But we're going to focus on that a little bit. So I don't want to confuse you when all of a sudden tomorrow I'm like, we have to go this way because I just want to prep you for that since you asked that. Flynn.
On like step 4, would it be wrong to, after saying angle 4 is congruent to angle 5, on step 4 would it be wrong to say like just angle 4 is equal to angle 5 and then put like definition of congruence.
Yeah, you could do that. Yep, and then you could use substitution. There's no real reason to do that in this one because then we'd have to get back to the congruent. So we'd have to use definition of congruent twice. Does that make sense? So you're just kind of expanding all of these. But I get what you're saying. We could go that way. All right. So there's the first proof we see in this chapter. Now, our last theorem. If we have parallel lines, and they're cut by a transversal, and we have same side interior angles, do these look congruent? Do they just on the surface look congruent? 1 and 4. They shouldn't because they're actually supplementary. So this one's different. It's supplementary. They're supplementary, not congruent. So alternate interior, congruent. Corresponding, congruent. Same side interior, supplementary. Keep those things in your mind when you're doing these. Same side are those weird ones. So now we can go, let's make K and N parallel. So we can go if K is parallel to N, then be careful here because we can't put angle 1 plus angle 4 equals 180. Look at the word. You have to use the word they say. All we can say is angle 1 and angle 4 are supplementary. Could we, if I was doing a proof, could I change that to measure of angle 1 plus measure of angle 4 equals 180? And if so, what would I have to put next to that step? I'd have to put the definition of supplementary. So we can see on a proof I just have to do one additional step. All right. Are we good on those? All right. Then let's move on. I kind of picture this as the puzzle kind of lesson. It's a puzzle lesson where we have to get from one angle to multiple angles. I'm also going to notice before I begin anything, all lines are parallel. All lines are parallel, so that means we can use alternate interior angle. I can use corresponding angle postulate. I can use same side interior. We can also use vertical angles. We can also use linear pairs. So I started with 105 degrees. That doesn't mean I'm just going to start with angle 1. We're going to start at the very beginning. That's at 105. So that's my starting off point. So we're going to start right here. Does anyone see an angle that you immediately know the value of? Everett? Angle 7. What does angle 7 equal? 105. And you know what I'm going to do? I'm going to go angle 7 is 105. I'm going to go ahead and write that here, 105. And I'm going to go over here. I'm going to say 105. And I'm going to get used to putting a reason why. So I'm going to put vertical angle. And maybe theorem. All right, that's how I justify my answer. Notice how it says justify your answer? Put a theorem or something down. All right, I have 105 for 7. Griffin, you have your hand up? Yeah.
Is angle 5 also 105?
It will be. Can I do one step, though? Just one step. Because I don't have something that goes from here to here. I do. Wait, I do. I'm sorry. How'd you get from 105 to 5? Corresponding angles. I'm sorry. I put my own, because everyone's going to go different directions on this. So 5, we can put 105. And Griffin used corresponding angle.
Do you have any tissues?
Postulate. On that blue thing. Got to keep our head up. All right, so we now have 5 is 105. I got 7 is 105. Someone new? Do you see another angle? Might want to get in this early because we're going to run out. Yep.
Would 4 be 75?
Why would 4 be 75?
Because of complementary angle.
Not complementary angle. Same side interior. I agree with that. So we can say 4 is same side interior. So they're supplementary, which makes that 75. Yep, I agree with that. We just got to be careful on the words we use. So that is same side interior for 4. 4 is 75 for same side interior angle theorem. All right, yeah. Jake.
2 is 75.
2 is 75. Let me go with you. Why? Corresponding angles. Can we all look at number 2 real quick? Make sure you're looking at it with me. We use corresponding angle postulate. Could we have used same side with 5 and 2 as well? Yeah, so everyone's going to go kind of a different way. Don't get bogged down in the way we're going. Stick with me, but we could have gone different ways to get here, so you might have different reasoning on here. All right, what's next? Someone else, someone new. Who hasn't given me one? Yeah. Will.
Angle 6 would be 105.
Angle 6 would be 105. Why did you pick that?
Corresponding.
Corresponding angles would work. Alternate interior angles would work. Linear pair would work. There's multiple ways to get to 6 being 105. But you use corresponding angles, right?
Yes.
Corresponding angle postulate. All right, Mason.
3 is 105.
3 is 105. Why? Vertical angles or corresponding angles as well. Or alternate interior angles. So we had a lot of ways to get to 3. 3 is 105. Lots of ways to do. Can you remind me what way you did it? Vertical angles. That would probably be what I would do. Vertical angle theorem. Come up all the way to the front, Junkie.
Would 1 be 75?
Would 1 be 75? I don't know. Justify it.
Yeah.
Sure.
Yeah, vertical.
Vertical or alternate
Same.
interior angles.
Oh.
Probably not same side, because same side, if I was looking at 1, I would have to get this measure first. Okay, so we have alternate interior with this 75. I got vertical angles there, so 1 is 75. You said vertical angles, right?
Yes.
Vertical angle theorem. Well, do you have a question? Oh, no, you already grabbed one. Who hasn't grabbed one? Otherwise, Will can snag it. Well, you're going to snag 2? All right, what do you got?
It would be 105.
It'd be 105, and why?
Corresponding to angle 6.
Corresponding to angle 6, corresponding to angle 3, same side to 75. Linear pair to angle 1. We got lots of ways to get there. We use corresponding angles to get to 8. All right, so it's kind of like a puzzle. Go around it, solve it. You can expect one of those on probably an assessment of some sort.
Would you do this like form of proof, maybe? Or
We could prove. Yeah, we will have proofs. We're going to do those tomorrow, where it's basically, show me that 5. So if you look at 5 and 7, see how they're congruent to each other? We'd have to prove it. So we'd do something like, vertical angles, corresponding angles. So this is a setup for a proof, how we're going to prove stuff. So good eye on that. All right, the next thing we're going to do is we're going to go ahead and we're going to find the value of y. Now, this is a complicated one. Flynn, you got an idea?
I had a question.
Yeah. Oh, I'll go back here then.
Measure of angle 6, you found 105. Would you do that because it's what's called corresponding angle to 7?
Corresponding angle to 7? Yep.
Okay.
We could also say it's a corresponding angle to 8. I didn't write it down, but we know 8 is also 105. We could also say it's alternate interior angle to the 105 that was listed. Flynn, I don't want to confuse you, but this is also a linear pair. So you could have said, 4 and 6 add up to 180 because they're a linear pair. I could have made them supplementary, just like same side. Lots of different ways. All right, questions? All right, pay attention to this one. This one gets a lot of people. Highlight your parallel lines. Highlight your parallel lines, because I've said we need to do that more often. So I'm going to highlight my parallel lines. Now, this one's a confusing one because don't highlight this transversal. I'm going to highlight a transversal that won't help you. That transversal won't really help you until we know more about triangles. Now, the reason why this won't help me is because 40 and right here are alternate interior angles, but that doesn't help me solve for y. So I'm going to go back and I'm going to draw a different transversal. I'm going to draw this transversal. And I think this goes back to Griffin's question on the homework. It was the one where it listed a big angle. It wasn't numbered. We had to use letters for it. What I want to point out here is we have same side interior angles. We have same side interior angles, but we got to be careful about those same side interior angles. My same side interior angles would include this 80 right here. But the same side interior angle would not be y and it would not be 40. It would have to be this entire angle. So it would have to be this entire angle to be same side. Maybe it makes a little more sense when I have these colored in, but these two would be same side interior angles. It's not y, it's not 40, it's actually them combined. This is using the angle addition postulate to say, hey, this is a really big angle, but a big angle is comprised of a small angle plus another small angle. So to get the one I have dotted there, that's actually y plus 40. So I'm going to go ahead to solve this one. We know same side interior angles, are they congruent? So they add to 180, right? So one angle plus the other angle equals 180. I'm going to go ahead and put that. I'm going to put angle 1 plus angle 2 equals 180. Well, instead of angle 1, I'm going to put y plus 40. Plus, and the parentheses are just there to show it's comprised of one angle. That's one angle I'm talking about. Y plus 40 makes one big angle. Plus that 80 equals 180. Now, like I said, the parentheses are only there to show something because if what's in front of this is a positive 1. If I distribute that, that doesn't change anything. So this is really just y plus 40 plus 80 equals 180, which is going to give me y plus 120 equals 180, which gives me y equals 60 degrees.
There's a different way to go about that, right?
Yes. Yep. Especially if you know things about triangles. All right, so that's 60. Does that make sense? But Patrick, I would like you to have this in your notes because sometimes you have to do it this way where you combine those angles, or at least you understand what I'm talking about. All right, our next one can be confusing to people because of how it's drawn. It's drawn like a trapezoid. But my question is, does it have parallel lines? That means we can look for alternate interior angles. We can look for corresponding angles. We can look for same side interior. So my first idea is not to make it super complicated. I'm going to look at if these angles are any one of those three things. Now, are these alternate interior if this is my transversal? So I'm looking at this being my transversal.
Yeah. Oh, wait.
Same side.
Oh, they're same side of the transversal. Are they between the two parallel lines? Yeah, those are just same side interior angles. And what do we know about same side interior angles? They're supplementary. They're not congruent, they're supplementary. So I have to have an angle plus an angle equals 180 here because these are same side interior. Same side interior angles, if I use the theorem, it says, oh, that must mean that 3y plus that y plus 20 equals 180. Now, once again, parentheses only matter if I have like a bigger number than 1 out front or if it's negative. I don't, so they just disappear. That means I have 4y. I'm going to go ahead and cheat this a little bit. I'm going to subtract 20 from both sides right off the bat. I'm going to have 4y equals 160. That would give me y equals 40 degrees. Yeah, go.
How would you know that the two angles are on the interior and not the exterior?
Because of the way the parallel lines are drawn. So if it's between the parallel lines, it's on the interior. So we can kind of picture that this would go on forever. So if I was highlighting the interior, it actually goes on for infinity between the two lines. Even though this ends, it's technically a full line on top of there. So what can help you in this regards is some people will actually extend this line. They'll go, well, I have that line, I have that line, and they can see the interior a little better that way. You can always extend parallel lines if it makes it easier to picture things, especially for alternate interior angles. Sometimes it's really nice to extend those lines. Go ahead. Yeah. Guys. So we're proving an angle relationship in the last one. We're proving an angle relationship, and I'm going to actually prove it incorrectly. I'm going to prove it incorrectly to demonstrate something, okay? So note, this is how some people are going to do it. I just want to show you an easy way to do this and still get most of the points, if not all the points, on like a test. And then we'll go over why it was incorrect tomorrow a little bit more. All right, so the first thing I'm going to go is I'm going to state the given because I want that point. It's so frustrating when I grade this stuff and you don't write the given and I have to take a point off right away. Yes?
You want us to write this even though
Yes, yes, yes. Because then tomorrow we'll go through one that's similar to this and how I would do it more correctly. I just want to make this stuff accessible. Some of us aren't great at proofs, and this might be the way that we can enter this proof. And it'll go off to Michael's comment on substitution versus transitive. All right, so this is a quick way just to get to this proof. I'm on test, and I'll probably get most of the points anyway, even though there's a small mistake in it. My second step, in fact, I'm just going to write 2, and then we'll talk about this. All right, so we have to prove that 1 and 8 are in fact supplementary. We need to prove that 1 and 8 are in fact supplementary. So I need to prove 1 and 8 are supplementary. Now, we cannot go from here to here directly. Is there something I could do with 1 or 8? Yeah.
Oh, 1 or 8?
Either one. What are you looking up there? We can use 1 and 5 or corresponding. That gets me closer to 8, right? So our goal is to make like this puzzle. I want to get from this 1 to this 8. Well, I can go from 1 to 5. And it looks like 5 is attached to 8, so I'm closer there. So that's a great way to start. So I can go angle 1 is congruent to angle 5. And that would be our corresponding angle postulate. What are 5 and 8? What do they form? They form a very specific shape that we've covered. Yeah. A linear pair. What's a linear pair equal in measure? 180. So let's first say that they're a linear pair. So I'll go angle 5 and angle 8 form a linear pair. You know what, scratch that. I'm going to do this the 100% correct way. I don't want to do it the wrong way. It just hurts my soul a little bit to do it the wrong way. We're going to do it the correct way. All right, and this is going to be the definition of a linear pair.
Is this the correct way?
Yeah, this will be the 100% correct way. I hate doing stuff the wrong way. I'll talk about how you might have shortcutted this, okay? I will talk about how you could do it the wrong way and still get most of the points. All right, what does 5 and 8 equal if I add them together? 180. So we can go in the next step, say measure of angle 5 plus measure of angle 8 equals 180 degrees. I might have written a little big. What in our postulate and theorem sheets says that linear pairs equal 180? Be careful on this one. What do you got? Not the angle addition postulate. There's something that says linear pairs equal 180 degrees. We can take out our sheets. This isn't a quiz. Remember, on all the tests and stuff, we can take that out. We can look at it. Everett? Definition of supplementary is not correct. That says if they're supplementary, then they equal 180. I want something that says if they're a linear pair, then they equal 180. Will, I'll give you a second chance. The linear pair postulate. Not the theorem, not the definition. If you look at the linear pair postulate, it says it equals 180. Linear pair postulate. So here is the shortcut that some people use. They'll say 1 is congruent to 5. I'm going to substitute that in there. I can substitute 1 in there. Did I ever say the measure of angle 1 equals the measure of angle 5? Haven't said that yet. I should have probably said it right here, but at first I was going the wrong way, so I'll just put it at 5. It could be like, oh, I forgot. I forgot to do that, so I'll make a step 5 and say that. Measure of angle 1 equals measure of angle 5. And that would be, how do I get from an equal sign to a congruent sign? Definition of congruency. Yep, definition of, and I'll just put the congruent symbol there. Now I have 1 equals 5. Well, can I put 1 in this statement here? Yes, and I'll use substitution. Substitution works here because anytime you're replacing an element of an equation, it's usually substitution. So step 6 would be measure of angle 1 plus a measure of angle 8 equals 180. That would be substitution. Are we done? Did I ever say they're supplementary? No, I have to say the words. I have to say the magic words that angle 1 and angle 8 are supplementary. Now we're going to use the definition of supplementary. Do you guys see how this is 7 steps? 7 very particular steps? Are we all going to be perfect and get all 7 of those steps? No. Here's my advice to you on this stuff. If you would have said something about corresponding angles, if you would have said something about linear pairs, that's most of the points. If you would have done this, and you would have done, so let's talk about this. If I just did step 1 and said it's given, and put ... and put I know it has to end here, that's 2 out of 6 points. Get another 2 points for just mentioning corresponding angles and linear pairs. You get an additional point for trying to put it in a proof. You get 6 out of 6 if you get it correct. So you can get 5 out of 6 points by just starting and ending and understanding linear pairs and this and muddling through here. So some of you will get your test back and it'll be not a great proof, but you only lose 1 point because you said all the key things. What I'm trying to get to you is don't get bogged down in proofs. Don't go, I can't do proofs. If you can't do proofs, that just means you get 5 out of 6. That's not a bad trade. That's not a bad trade as long as you understand givens and you explain something to me. People did that on the test. They said, Mr. Pabian, I know I need to use vertical angles. I don't know where. Hey, you mentioned vertical angles. And you tell me what vertical angles do. Doesn't have to be in proof. Just explain that stuff to me. That's why I have kind of explanation down here. How you could just explain stuff. If you couldn't do the proof, you could just explain stuff. All right, questions? Tonight we do